My name is Kevin Lombard. I'm a professor of horticulture and a superintendent of the Agricultural Science Center at Farmington. We're a 250-acre research farm, part of the Agricultural Experiment Station system. We're located on the Navajo Nation, just south of Farmington, on the mesa that some folks may know as Navajo agricultural products industry. And we serve the Northwest New Mexico area, including San Juan County and the Navajo Nation. So thanks again for the invite. And I wanted to shout out also to the folks that are in attendance. Some of them are including Michael Patrick and Bud Lopez, Jesse Jim. I know you all are working in the field. And so I'd like to, at the end of the presentation, maybe there's time that y'all can introduce yourselves. So why compost? So it's pretty simple to me, is to reduce landfill waste. Taking food scraps, for instance, into the garbage can is a waste. It's a waste of nutrients. It's composting can return nutrients back to the earth, and I'll cover a little bit on nutrient recycling here in a bit. But also, composting is basically fertilizer to your garden, and synthetic fertilizers are expensive, and this is just becoming a bigger issue with the war in Ukraine, with inflation. This is hitting everyone from large-scale producers all the way to backyard gardeners pretty hard. So composting makes a lot of sense, especially given just the price of fertilizers. So just to kind of give you a geeky scientific view of what is nutrient recycling and why does that fit into a composting. So when you're taking something like food scraps, you're taking the nitrogen and the nutrients that are contained in biodegradable products, and you're returning it back to soil. And nitrogen is one of the biggest nutrients that's required for plants. It's essential. It's an essential constituent of proteins. And chlorophyll, which is the green, that makes the leaf green in plants. So nitrogen is really important in nutrient plant physiology. It's very abundant in the atmosphere, but it has to be fixed or converted to a usable form. And this is very energy intensive if you're looking at converting atmospheric nitrogen to a synthetic fertilizer basis. And so by composting, you're returning this nitrogen that was in living tissues at one time. Through decomposition, you're returning that to soil and into a plant available form. Plants will take up nitrogen and nitrate, NO3 or NH4, and so that's just a little bit of some background on nitrogen physiology in plants, just to illustrate it here. Looking at how nitrogen in the atmosphere can be converted into a plant available form. It's either converted through microbial action or, as I mentioned, decomposition through animal waste or animal decomposition, leaf composition. And this is through several different processes that eventually return back to plants, living tissue. It's a cycle of life, the circle of life, think of it that way. So what is composting? It's biological decomposition of organic debris. It's more than just throwing things in a pile and letting them rot. It's if you're looking at compost pile, you're wanting to, introduce balances of nitrogen or carbon nitrogen balance. And it's also pitting a heat process to it. This is when you're basically stimulating microbial action to decompose something like food waste or something that's biodegradable, like paper. Some papers are biodegradable, manures, and that kind of thing. So there's one type of composting where you're heating this pile of organic material up, and this doesn't just happen by hitting it in a pile and just like walking away from it. There's a certain processes to it that involve making sure that you have water. And so having a dry compost pile will just sit there and it'll never really decompose. It'll just become kind of a rot pile. So there's water involved, there's mixing, there's aeration, adding oxygen, and this combination creates a thermophilic or heating, followed by kind of a slower decomposition phase or aging. And it usually occurs over several months. It's not something that just happens in a few days or a few weeks. And you really can tell when you have a nice compost pile. If you're doing this in the winter, you can actually stick your hand into a compost pile and actually feel the heat, or you can sometimes see steam rising out of a compost pile around here. So inputs and outputs, what goes into a compost, what goes into composting? So you have a raw organic materials as carbon source, nitrogen, which is organic. You have a combination of microorganisms, water and oxygen. I mentioned that. And this is goes through this process, thermophilic process, creating heat. You get water vapor and carbon dioxide as byproducts. There's US EPA guidelines suggest that having a compost pile at 130 degrees Fahrenheit is ideal for killing off some pathogens that, like E. coli. There's some concerns about food safety when you're using compost, and manures are the same. So that's where that thermophilic or heat process comes into play. You want to make sure you have a nice hot mixture to try to decompose some of those pathogens, like, or reduce things like E. coli. As I mentioned, a compost pile is more than just throwing food scraps on. This happens to be from a partnership we had with San Juan Regional Hospital, where we're getting their food scraps, bringing them to the Science Center and mixing them with farm waste, like straw. That's kind of layering in there. The kind of the fresh fruits and vegetables that you see here, these are the peelings from like cantaloupes. You can see those are actually adding moisture into the compost pile as well. And it doesn't stop with just this. There's mixing involved. So but you can see just even the service that the hospital in Farmington was providing, they were generating a lot of food waste that otherwise would have been going to the landfill. So this is, if you're interested on composting on multiple scales, you can start with your backyard, your home kitchen scraps. But if you're looking at maybe something on a larger scale, you might want to go and talk to restaurants or institutions like senior citizens homes or hospitals. And you might be surprised that they'll have a lot of food scraps laying around, and they'll actually give them to you because they want to get rid of them, and it's saving them money for having to not have to take the landfill. It's something to consider. I mentioned that compost piles are not just a debris heap throwing into a pile, can, or bin. It takes time, and organic debris will decompose, but it's just not rarely going to heat up if you don't mix it. And that's where, in my experience, like I kind of look at my own compost pile as a form of exercise too. Like I'll want to get out there maybe once a week or once every other week with a shovel and it over. On a larger scale, I'll actually use a tractor to scoop up the pile and mix it. But that's the key to having a successful composting operation, either on home scale or larger scale. So as I mentioned, mixing is important. You can use a tractor. You don't want to just throw something in a static pile and let it sit. You can actually see in this photo where the steam is coming off that pile after it's been stirred, and that's a really good sign. That's like telling me that there's microorganisms in there that are breaking down the organic matter and breaking that down into a usable soil amendment. Yeah, are there any questions up to now or any comments? Anybody else have any experiences that they'd like to share?
Not so much experience, but what's the difference between using cattle manure, sheep manure versus your food scraps?
So I'm going to get into that a little bit in a bit. The difference is you get a big kick of nitrogen when you throw manure into a compost pile, and you're actually feeding microorganisms that are involved in that decomposition process. And so you can, in my experience, you can get a good, pile cooking, or so to speak, or heating up with throwing some manure in to add nitrogen to the mix. There are some trains of thought about, there's food safety issues with E. coli and some pathogens that are associated with manures. I guess in my opinion, the use will dictate the application will dictate what type of manure you want to throw in. And then, in my field, and I'll get into this a little bit, my philosophy I'll get into a little bit later, is that the benefits outweigh the risks of using manure and compost. Anybody else have any thoughts? Okay, well, these are just some different kinds of systems. You can start with a pile. I showed that earlier. That's the simplest form. That's how I operate. I'm pretty lazy when it comes to these things. I just want to get it going, and but that has its drawbacks. Having just a single pile. With this type of system where you have things that are kind of separated into different bins, you can use like anything from cinder blocks in this example, or pallets, old wood pallets. You can kind of structure your composting, and this maybe applies for larger scale operations where you're starting a new pile, and then you're moving your pile over to another bin and letting it age, and then your final finished product is at the third bin bay. We see that, like, say a good example of this would be like, say, in a greenhouse operation where you're taking like used potting soil or something like that, you're adding food scraps or something, you're gonna have a little bit more inputs, bigger piles. This may facilitate the use of a tractor to be able to come in and scoop up and move things from one bay to the other. It helps with keeping track of the pile and its aging process. These are just some ideas I pulled off the web. Just Googling, composter into Google. I found any number of different ideas that are out there, from these pallets to fancy wood structures. On here, I don't know if you can see me moving my cursor around, but they're real simple, like tumbler ideas, where the idea is you're putting your food, your yard waste, kind of in proportioning it into a barrel, and you're rolling that, rotating it around. That's basically taking the work out of using a shovel or a tractor to stir the compost. There's actually commercially available tumbler systems out there. You can spend hundreds of dollars on these if you want to. But there's a lot of nice ideas on the web about how you can just make something out of an old food grade container. Like, so here's one with a garbage can that's put on with a pipe through it, where you can just turn the garbage can around in circles. I've seen pictures where somebody will put a food grade, these blue 55-gallon drums for food grade, and that's important too. You don't want to just get an old 55-gallon drum of used hydraulic from a hydraulic oil, or you want to make sure that what you're using is food grade or new. But I've seen photos of just where they're on the ground and somebody's just rolling it. The idea is you want to keep mixing, and you want to add water. That's important, especially out here in the desert where things dry out a lot quicker. Putting a garden hose on a compost pile and letting it kind of soak in is a good idea, in my opinion, just to keep those microbes active. Here's one with some hay bales, utilizing it that way. So it's pretty much the sky's the limit. Here's just a Tupperware bin. You can do this under your under your kitchen sink. There's vermicomposting with worms. There's any number of takes or ideas on this concept. So I would encourage everyone just to go and see what's out there and see what other folks get ideas from, what other folks are doing. Just some successful summaries of composting. You're adding your nitrogen. You're adding nitrogen if your carbon ratio, which would be like leaves or yard waste, is really high. That's where that manure might come in, to add a little bit of nitrogen source. That's a manure source. Adding water, I mentioned that, to about 50% moisture. Mix it. There's some ideas about layering it. I'll get into another composting type of system that's fungal based. That's kind of new to me, and so I'll just throw that out there. That is more layered and less mixture. And ensuring aeration is really important. If you get an anaerobic compost pile, it'll start smelling. It'll appear kind of oily. Have that kind of, I don't know, swampy smell to it. Then pile maintenance, mix it every few days until your heating stops, and then you mix it monthly. Add water when you're mixing, because in my experience, you're noticing that compost material tends to be kind of hydrophilic, which means it sheds water. It doesn't actually absorb water. So be sure to add water to it while you're mixing, and then again assure the aeration. But my experience, like sticking my hand into a compost pile and seeing that's mature, and seeing like it's very organic, earthy smell. It's very rich and crumbly. It's fine layered. It doesn't have like big chunks in it still. And then earthworms, seeing earthworms in it is a really nice sign. Sorry, I had some people that are admitting into the meeting right now. Any thoughts or any other ideas before I kind of keep moving?
I've seen compost with manure, and what they did was add hay to it. Does that help it any, or is it the risk for E. coli still present?
So you're adding that carbon source, or yeah, and that hay. So like grass clippings or leaves, like the leaves that you rake up from your yard, for instance. That's probably what you're seeing. You're seeing sort of like proportionally layers of manure, which is a high nitrogen source, to the hay, which is a high carbon source. And that he is supposed to help reduce that risk, that food safety risk of E. coli. So that's why you need to get your compost pile really hot in the beginning. I hope that answered your question.
The question in the chat box from Joe, it reads, can you repeat on manure and compost?
So how about so I'm going to cover that here in the next few slides, if maybe that'll help. But adding the manure, that's a source of nitrogen. And you can do the same with like maybe a synthetic fertilizer. If let's say you have your compost pile and it doesn't seem to be heating, you have added water, but you're not getting that warmth. You might want to throw in a little bit of maybe a synthetic fertilizer, or the manure is the best, and in my opinion, because it's just around, and that's like basically feeding the microbes that are breaking down, or part of that decomposition process. Kind of without those microbes and microbes and earthworms chewing down on the material, it's just going to sit there. It may like partially rot. You'll have chunks. You won't have a fine, sort of like your goal is to have this sort of fine soil like structure. It's not going to be soil. It's going to be really friable. It's going to be dark coloration. It's going to smell earthy. It's not going to smell, I don't know, like, how fresh manure smells. It has that certain smell to it. You're going to, a finished compost, it's not going to have a strong odor to it. Kind of a raw compost will have some odors to it. So adding manure,
ammonia odor to it.
Yeah, ammonia odor to it. Exactly. So the manure will add the nitrogen to help the process out. I'm going to cover this here in the next couple of slides. Next few slides. So yeah, I won't heat. It's too dry or maybe even too wet. It's anaerobic. It'll have that swamp smell to it, like standing water smell. The components are separate. You need to mix. The pile is too small, so you need to add more. You add more material. This is particularly important, like say in our conditions here, where it can get really cold in the winter. A good compost pile is going to be like still throwing off heat in the dead of winter if you have it properly maintained. And then the pile stinks, yeah, too wet. You need to aerate it. Your carbon to nitrogen ratio is too low. You need to add more residues. maybe you have too much manure in it, and your components are separate, so you need to mix. So here's another type of compost system that I've gotten recently introduced. It's called the Johnson-Su bioreactor. And in places I've seen it around the state and some cooperative extension offices also. And the idea is that you're going to throw leaf material in here, and you are going to just let it, and you're going to have these aerated tubes, and you're going to let it kind of it has no heat really involved with it, but fungal, you're promoting this fungal mycelia, and the thought process is you're inoculating your soil with fungal mycelia. I'm not really covering it too much, but it's something that I think we need to do a little bit more research on, see its effectiveness. But just keep this in mind: the Johnson-Su bioreactor. And then there's some of this at the Alcalde Science Center is where I got introduced to it. And yeah, at any rate, we know as soil, for healthy soils, having that fungal mycelia in the soil helps to extend water scavenging by plant roots in these fungi plant root interactions. So that's why it's kind of thought to be another way of inoculating soil with this type of system. And the work was done all day, and so I'll try to get you some of the information on this, Jesse, so that you can send it out. I think there's some extension circulars on it now, but you can kind of see in this photo right here where they have these PVC pipes that are aerated. Just throw leaves in it. There's no manure thrown into it. It's not allowed to heat up like the regular compost that I just covered. And then I wanted to cover real quick kind of some, I'm a scientist too. I like to try to fit an experiment hypothesis to these things. And I was dealing with some agroforestry questions that were related to nutrients in these plots at the Science Center Farmington. And we started looking at composting biosolids, and this is going to human manure, or what they have at Albuquerque. They have a huge composting on a massive industrial scale where they're using basically sewage sludge that's dewatered from the wastewater treatment plant, and they're throwing leaves and debris into it and mixing it up, letting it heat up for 6 months, and then distributing that to the public as a compost for folks' yards and gardens in Albuquerque. So I thought it was a compelling research question to put this on these trees. They're non-edible crop, and it's particularly relevant now that fertilizer prices are going out the roof, to further, circle back to some of these ideas of using compost on a more large scale for looking at cropping systems. I call it human manure. I consider human manure, my philosophy on it is something that we should be utilizing. So anyways, this is the topic of some work we did a few years back. And the problem was we were having an iron chlorosis issue in these tree plots. And we were, this was related to our soil conditions. We have really high soil pH here, lots of calcium in the soil. We are utilizing a very expensive chelated iron fertilizer. And we wanted to ask the question, can these composted biosolids correct the nutrient disorder in these tree crops? And then this is what I was talking about in Albuquerque. They have this warehouse is literally the size of like 2 football fields, and they're utilizing a sewage sludge that's dewatered and mixing it with 3 parts yard waste to 1 part biosolids. And then that's what it looks like in the bottom right when it's fully mature after 6 months and sieved. And this is distributed. And but the questions also is that the benefits must not exceed the cost to the environment. So we also looked at things like heavy metals in this amendment, soil amendment. But it's real fast. Our soil pH is very high here, so we have issues with iron chlorosis and things like some fruit trees, and our nitrogen. These biosolids here on the right column, very high in nitrogen. I just wanted to point that out, as opposed to our soil in Farmington, which is very low in nitrogen. So these composted biosolids are a high source of nitrogen. And also in phosphorus, potassium. I'm letting some other people in. These micronutrients, which are also important for plant growth. So if you look at the soil that we have in Farmington, very low in iron, available iron, and these composted biosolids were very high in iron, available iron. And then some of the secondary elements also, you can see sort of the enhancement. One of the issues with using manure, any type of manure, is the sodium content. So I always have to caution folks that any type of fertilizer, including compost, could have the effect of adding sodium to the soil, which is something that we need to be careful of around here. I just wanted to show you how we applied it with a fertilizer spreader. And we compared this to a very expensive chelated iron fertilizer. And we found that just looking at these biosolids, that's what this is abbreviated, we found that our total chlorophyll, which is measured by the SPAD meter. I'm getting really geeky here, I'm sorry, but you have to forgive me. You invite a scientist, you're gonna get some geekiness to it. You increase your chlorophyll with this compost. This is the control, which is no treatment. And, this is what the trees looked like after a few years. This is how they were planted originally as cuttings. After 13 months of amending, again, we saw this iron level increase in the soil compared even to the expensive fertilizer. So was an impact, and we did see significant increases in both growth and all of our tree growth parameters, the height, the diameter, the height, dpH, the wood volume. So why is this important? I mean, this is just a science-based experiment that showed that composting was beneficial to this particular wood plot. That's what the bottom line was. And then when you looked at, and Michael Patrick, you'll appreciate this. I'm not an economist, but when you looked at the cost of the fertilizer versus the cost of the biosolids from Albuquerque, there would have been savings, except for we had to truck this in on a semi truck. That's something that has to be considered. Now, if you're looking at like on a municipal scale, like in Farmington or Gallup or Crown Point or somewhere, you have a wastewater treatment plant, and this might be something for us to consider. I think we have to start considering the use of manure, and we have to consider the use of human manure maybe for sustainable purposes. But at any rate, I was just curious about it. I looked around on the internet this afternoon to see like, well, what are other people doing about human manure and composting? And there's actually quite a lot of activities going on around this subject. And I got really exposed to this idea when I was working in Africa. And this is because can't afford synthetic fertilizers, and food production is important and is a as important as, as a livelihood. There's not such an ability to go to a grocery store. And so the sustainability factor for considering composting manures, animal manures, human manures, is something that I just wanted to throw out there to group, maybe see how people feel about it. In this particular system that's in Africa, the urine is actually separated from the solids, and this prevents the smell, odor issues, and the urine is actually considered a type of liquid fertilizer, if you can believe that. And then, there's a book on this called the Human Manure Handbook. And so it's just something that I want to throw out, and because, with uncertainties with climate change, cost of fertilizers, I believe that these are things that we need to consider for sustainability purposes, realizing that there are food safety that needs to be considered, and those kinds of things. And so there are some resources for some science-based approaches to this. So I guess in summary, composting will reduce landfill waste. It's just a good way of taking those food scraps, those any kind of biodegradable products that that you can, otherwise not throw into the landfill. It's putting nutrients back onto the completing the circle of life, death, and life again. The circle of life is what composting really boils down to. There's many ways of composting, and it just depends on your scale. And I guess I'm going to end it there and just open it up to discussions at this point. I really appreciate the opportunity again to present today.
Okay.
Any
so
questions?
I have a question. I have a question on the, using sheep and cattle manure. I only say that because it's readily, it's available everywhere, with livestock producers. And, how long will it take before it's ready to add to the garden? Because I know the smell that you're talking about kind of smells like eggs or something like that. If you do it right, how long will it take before it's ready to go into the garden?
I guess that's a really good question. I guess in my experience, I always start a new pile in the fall when the leaves drop. And so that's sort of my basis for my own composting. Is I get my big pile of leaves that would otherwise, that's kind of a resource. So that's my bulking material. And then I have my food scraps layered onto that. Inevitably, because I have a small farm also that my wife mainly administers that, but there's always some kind of waste involved with it. There's some rotten vegetables or something that don't get sold, and so that goes into the pile. This is usually around October, and I'm mixing it. I'm doing this through the fall, the early fall, the winter. I'm checking it for heat. I'm really pleased when in December it's hot, and then it kind of cools off. I'll let my pile go for almost a year before I consider it good to put on. And I put my compost on to just around my garden. I don't generate enough to put on back onto the farm, but I do generate enough to put it around like a fairly sizable garden that I have around my house. And if I'm doing like a tree planting, I'll always mix like, equal parts of compost to soil in the hole, in the backfill hole, if I'm planting a tree or shrub. So I would say a minimum of 6 months. And just again, going off of like if it's chunky, if you can see like parts of leaves or straw or manure, then you need to add more water, you need to mix it some more, um, and let it go a little longer. If it's like real friable and it's like a pretty uniform homogeneous mixture of, it's basically just black, organic, it's friable, it doesn't have a strong odor, then it's good to go.
Okay. Okay. That's good information to know. And so, covering it versus leaving it open, what's the best way? Does covering speed up the process, or, what does that do for composting?
That's a good question too. Like the covering will reduce your water loss out of it. So it might be a good idea to throw a tarp on top, or if it's like a tumbler system, you're keeping it closed and it doesn't dry out very fast when you have a cover on it. With my compost pile here at my house, I keep it in a pile and I just mix it, make sure it's mixed. I haven't really gone the extra step to cover it. I suppose that covering it will make it mature faster.
Okay, a couple more questions. So compost, where, within the Four Corners region can we purchase a large amount aside from Home Depot, if we need it by the truckload or trailer load?
Yeah, so that's a hard, compost is a really hard thing to find on a commercial scale around the Four Corners. There's some operations up in Durango, for instance, that they're actually picking up yard waste on a commercial scale. I think it's actually part of the utilities. Um, and they're pitting bins with folks that are signed up for it. I know in Durango they have kind of a, I guess maybe what they call it, maybe a cost share, where if you are contributing food scraps into this commercial compost operation, you're entitled to get some of the compost back for your garden. This is also like on a municipal scale happening in places like San Francisco, where they'll actually have a separate garbage can that you can put out on your curb with all your food scraps. Around here in Farmington, there's not a lot of that going on. I think there's a great opportunity for communities, to maybe larger communities that are doing solid waste at the curb already. Maybe it's an opportunity for us to put, brainstorm out ideas of capturing those food scraps that would otherwise go to the landfill. Going into the Albuquerque composted biosolids example, they're generating it there by the ton, and I think they're just basically giving it away. Again, though, the cost of transportation up to Farmington can be very expensive, so that's something to consider. Albuquerque is the only other place I can think of to get compost on a large scale.
Okay, great. Thank you, Kevin. And then last question, soil testing. How can, our gardeners get their soil tested, and where do they go, to find the soil test kit, and then also to read the results?
Okay, so that's important. Soil testing is the foundation of understanding everything, anything and everything about your garden. So if you've never done a soil testing, it's worth the expense and time to do so. And there's some great publications that that are out there from NMSU Cooperative Extension about it. You can, around here, you can take it to the Navajo Agricultural Products Industry Testing Lab, the NAPI Testing Lab. They'll do it for a fee of about $20 a sample. And with a soil sample, you're wanting to dig soil about 6 inches deep, and you're wanting to, that's the reason where the plant roots are concentrated the most. So you don't need to go very deep. And you want to make sure you're getting a soil sample from a homogeneous, or, the topography looks the same. If it changes, you want to get a separate soil sample for that area. There's other online vendors like Ward's Lab or Servitech. Those are places that you can mail the sample off to, and yeah, it'll charge you a fee anywhere from they'll charge you a fee from anywhere from $10 to $20. Some of those some of those testing labs will give you an actual interpretation of the results, which is important, I think. Currently NAPI lab, I don't believe they give you an interpretation. They'll just give you the data. So you'll need to get with an extension agent or someone who knows how to read the data to get you back the results in a way you can understand it.
Great, thank you. And are you available, if say we get a producer, a gardener that gets some results, are you available to, assist them with reading their results and what their soil needs?
I can be available. I can also refer you to our specialist, Dr. Bob Flynn, who's over at the Artesia Science Center. He is an individual who will do that also free. But yeah, I think any extension, any cooperative extension office, I don't know, Bud, if you're still on the line, I wanted to give you a chance to maybe chime in if you're still around. But McKinley County Cooperative Extension, San Juan County Cooperative Extension, Bonnie Hopkins, the land grant offices at Dene College, Saley, or NTU Crown Point should be able to point you in the right direction also.
Can you hear me?
Yeah.
This is Bud. Yeah, you're welcome to call me or email me any of the results, and I can go over it and put a little interpretation together.
Bud,
Okay,
while you're on the
great.
line, can you just tell us a little bit more about yourself?
Well, I'm the new tribal extension agent, agriculture extension agent for McKinley County. I'm from Gallup originally, born and raised. I went to New Mexico State University to acquire my horticulture degree. I have worked in 5 states, but for the better part of 30 years, I was in California. I worked in the Salinas Valley, which is, if you are familiar, or on the Monterey Peninsula, if you're familiar, it's called the salad bowl of the world. I did a lot of work in native plant restoration. I did some work with native plant disease with UC Berkeley and UC Davis. Let's see, what else? I did all of the native plant propagation for I don't know if you're familiar with Pebble Beach. It's mostly known for its golf course, but it's a 6,000-acre property that's under perpetual preserve. And we were required to revegetate, eradicate exotics, and maintain the native forest and beach communities there. And like I said, I did that and several other things, seed hybridizing for American Taki Seed Company, and lots of that stuff, a lot of other stuff. But that's the highlights of my career and my background.
Great, thank you, Bud, and thank you, Kevin.
Yeah.
I believe that concludes our Q&A session, and then also on our webinar for this evening. I'm going to go ahead and launch a poll here for you guys to fill out, and this is just for evaluation. Let us know, how we're doing and so forth. So I'll give you guys some time, and again, thank you, Kevin, for setting some time aside this evening to talk about composting. I know there's a lot of gardeners out there that are, looking at different techniques to improve their gardening efforts, and this is one of them. And it gives them great insight on the whole process, as you explained, and the different options that are out there. So thank you. So next week,
just get out there and do it.
Go ahead. Right.
Yeah, just get out there and do it.
That's right. So next week, on Monday, October 17th, we are going to have Dr. Aaron Staffel, who is the Arizona State climatologist, talk about the Four Corners seasonal outlook, and then also talk about the drought. And that's what we will be having next week. Registration is required. If you go to our website at nsa.nmsu.edu and look under the upcoming events tab, and you will find the flyer there and the registration link. So that is up there. And then also our other programs that we have scheduled for October into November. Our website is there. If you guys have questions, you can email our project, nsaproject@nmsu.edu. And also we have all of our information posted on our Facebook page, and then also past webinars and this webinar are on our YouTube channel. If you need to get a hold of us directly, you can email myself there or Mikal as well. So with that, thank you everyone, and have a great evening. So the NSA project is a New Mexico Cooperative Extension Service initiative delivered in collaboration with the Net College Land Grant Office and Community Outreach and Patient Empowerment. This project is funded by USDA's Outreach and Assistance for Socially Disadvantaged Farmers and Ranchers and Veteran Farmers and Ranchers program. We currently have 2 field staff out here in Eastern and Northern Agency, which is myself, and then also our field specialist, who is Mikal Lantana, and then also our project director, Dr. Michael Patrick. We have 3 goals that we are accomplishing within our project. The first one, as you can see, is to improve the operations, profitability, sustainability of socially disadvantaged Navajo farmers and ranchers on the reservation. And then also, we are increasing Navajo farmers and ranchers' knowledge and use of USDA programs such as the NRCS, FSA, Rural Development, and Risk Management Agency programs and services, and those of other resource providers. Last but not least, we are increasing the local production and consumption of fresh fruits and vegetables and healthy food by Navajo families and individuals. So thank